Hello, my name is Ricardo Hannes, and this is my CS6795 term project. The topic of my paper was the impact of LLMs on software systems maintenance. Now, in terms of why the research matters, the software industry is undergoing massive transformation. LLMs like ChatGPT, Claude, and others are being used by developers to generate code. In fact, Google says that basically 25% of their code is now generated by LLM. And tools like Cursor, which is a developer IDE, is probably the fastest growing developer tool ever, and use LLM to help developers deliver code. The focus, however, has been on generation and not on maintenance, which is the majority of the software tasks in the long run, right? And software system maintenance involves everything from debugging code through basically writing tests to debugging issues in production and putting things into production and so on. So we sort of investigate the impact on maintenance for LLM generated code base. So we started research on LLM assisted code initially, and using Google Scholar and Archive to find papers, particularly in the sort of range in the last 2 years, 2023 to 2025, and looked across ACM articles and just generally reviewed papers as well as new findings. One of the things that became clear was that the cognitive challenges in maintenance were actually substantial, and so I shifted focus. I also looked at a framework that we could use to evaluate kind of the impact of a lot of these changes. And so, from the timeline below, from the initial focus all the way through adopting space framework for analysis is all there. So the research process and pivot. So the results, basically, the research question really is what's the impact of LLMs on maintenance of code? Hypothesis, LLMs have no significant impact. The alternative is that basically LLMs make your life easier. So sort of started evaluating and looking at stuff with respect to the SPACE framework, which looks at satisfaction, performance, activity, and collaboration and efficiency for a developer and teams. So the key findings really are that, LLM-generated code, 61% more complex, which sort of is against the null, reduced time and collaboration, and knowledge sharing in a team, so that's also null. 21% faster task completion with LLM, so that supports the alternative. And significant bucket effort is still required, so sort of mixed performance. When you look at the SPACE framework, there's prompt fatigue and unclear behaviors, again, sort of mixed results supporting either null or alternate. Performance, basically faster generation, harder compression against mixed. Collaboration, reduced team interaction, so this sort of supports maybe the null, and efficiency varies significantly by experience, so sort of mixed. So the results overall are inconclusive in terms of what's there. And on the right, you can see a diagram that sort of maps, the SPACE framework in orange to kind of the cognitive principles that I think are going to have to be the basis for any future analysis. So the conclusion really is that cognitive load and compression remain sort of key barriers to being really efficient in terms of software system maintenance, right? So you may get a bunch of benefits with code generation, but then you kind of lose it in terms of, how the person thinks about the code and debugging and other issues when it's delivered. The SPACE framework certainly helps us to analyze that because we look at human and technical factors. And certainly cognitive principles, as I showed previously, like CROM and working memory and distributed cognition, I think those are going to be the essential facets that we're going to have to use. So we've got to design and research LLM workflows that match how humans think and collaborate, not just how they code. So future work, sort of run more controlled cognitive studies using frameworks like SPACE to evaluate how LLMs impact real-world software maintenance and compression. I think putting everything in context will actually end up producing better outcomes, and we'll have a more comprehensive way of approaching workflows for developers. Here are some of the paper references.